So the surface tension, it is the tensile force per unit length along the surface of a liquid, and you can see that the droplets of water surrounded by air or a soap bubble, they have having the spherical shape. This happens because the molecules attract each other weakly, and the inside the drop, the water molecules inside the drop may be attracted equally in all directions by the surrounding molecules. So they will tend to uh, prevent the molecules from escaping that uh, bubble or drop by acquiring a shape which is having minimum surface area. That is, usually sphere is, we know sphere is having the minimum surface area. That is why this happens. Uh, and the surface tension is denoted by the big letter sigma, and it is force per unit length. That is Newton per meter. As I said, it is a tensile force per unit length. You can see some pictures on the PPT. This is a weight axe. Now uh, the next property is called cohesion. This surface tension, as I said, it happens mainly because of the cohesion. Cohesion means it is a property of fluid by which the particles of the same fluid attract each other. The property by which the molecules of the same fluid attract each other. That is called cohesion. But adhesion is another property. That means the fluid of different fluids, particles of different fluids uh, may get attracted. Particles of different fluids, or it can be a fluid and solid, may get attracted. This is called adhesion. So another property is capillarity. It happens due to adhesion property. So we have discussed surface tension. It happened due to cohesion, and adhesion and capillarity happens due to adhesion. Okay, now we'll move on to capillarity. It is the ability of a fluid to flow in narrow spaces without the assistance of and in opposition to external forces like gravity. If we dip a small tube in a vessel containing water, naturally we can see that water will move through the narrow tube upwards. That means it moves against the gravitational force. This property is called capillarity. And we have seen that in thermometer we have seen that mercury goes up. Then when we measure the temperature, we can see that when it is placed near the hot objects, naturally we can see that the mercury goes up. This is because of the property of capillarity. So we can see two images here. That is one vessel containing water and the other jar containing mercury. There is some difference in the levels of mercury and water. We can see that water level inside the tube is higher than the water level in the vessel, and in the case of mercury, the level is lower than the mercury level in the jar. Okay, so these two phenomena is called capillary rise and capillary fall. Capillary rise is tendency of liquids to rise in tubes of small diameter in opposite to external force like gravity. And capillary fall is just opposite to that. It is a tendency of liquid to be depressed or fall below or fall down in tubes of small diameter in opposite to external force like gravity. That is capillary rise and capillary fall. Now I will see the applications of a surface tension and capillarity. Okay, lubricating oil spread easily on all parts because of their low surface tension. That is one property. Surface tension, that is the application. Now, cotton dresses are preferred in summer, which because cotton dresses have fine pores which act as capillaries for sweat. Because through this cotton, the sweat goes out. And the dirt get removed when detergents are added while washing clothes because surface tension of water is reduced. We can see that when detergents are added, the surface tension of water is reduced, so that will remove the dirt. Now the capillary action works by drawing the kerosene or oil out of the fountain to the tip of the wick, where the flame heats the oil to a gas and ignites. We have seen that earlier, kerosene lamps and all, the kerosene will be at the bottom and we will put the wick on the top, but the kerosene naturally comes up through the wick. This is just because of the capillarity. Okay. Now drawing up of liquids between the hairs of a paintbrush is another and the fact and the drainage of constantly produced tear fluid from the eye tears are coming out this way, drains out and observed in thin layer of in chromatography also we can see that, and draws into the tips of fountain pen. Earlier we used to have fountain pens, and the nib, the ink poured in the bottom side will automatically come to the nib. That also happens due to capillarity. Now the next portion is properties of fluids. That is, first we will see the besides these properties, we will see the classification of fluids. Okay, this is the last portion in this chapter. Okay, ideal fluid and real fluid. The fluid in which there is no friction, that means it does not have any viscosity, it is inviscid. That means it does not have any viscosity, no resistance to flow. That it means it will flowability is maximum, it will flow continuously. That is called the ideal fluid. But no such fluids are available in the nature, because we have seen that whenever the liquid moves, the others will offer some resistance. The surface the surface through which it flows through will offer resistance, or the molecules inside the liquid will also offer resistance. So without friction, flow is not possible. So we have only real fluids, no ideal fluids are there. In real fluids means either liquid or gas tangential or shearing force are developed always whenever there is a motion related to the body, thus creating fluid friction, because these forces opposes the motion of one particle past the another. So we only have real fluids, no ideal fluid. Ideal fluid means 100% flowability, no resistance to shear stress, but it is an ideal case. In practical, we only have real fluids. Now, next classification is Newtonian fluid and non-Newtonian fluid. A fluid for which absolute viscosity does not change with rate of deformation. The absolute or dynamic viscosity does not change with rate of deformation is called a Newtonian fluid. You can see that in the graph, the shear stress and shear rate, it will be straight, and that is a slope. It is given in the picture. And now a fluid for which absolute viscosity changes with rate of deformation is called non-Newtonian fluid. Examples are paints, gels, emulsions, sludges, slurries, etc. Their viscosity changes with rate of deformation. So I think today we will wind up the classes. So tomorrow I'll send a link for our live stream session. Please come prepared. Please go through this PowerPoints and listen to my audio as many times as you want. Once it is clear, we can meet tomorrow through a live session. Then you can ask or you can clear your doubts, and I am looking for your response. Thank you.